This session is for AQA M1, topic is kinematics, and we're looking at question 2 from January 2011. So if we start by having a look at the question, so we have a velocity time graph. The velocity of a train varies as it moves along a straight railway line. We're asked firstly to find the total distance travelled by the train, secondly the average speed of the train, and then in part C, find the acceleration of the train during the first 10 seconds of its motion, and in part D, the mass of the train is 200 tons and we're asked to find the magnitude of the resultant force acting on the train during the first 10 seconds of its motion. So let's start by looking at part A and reminding ourselves that if we have a velocity time graph and we want to find the distance, then we do so by finding the area under the graph. So if you like, we could really just divide this up into 4 different areas. 1, 2, 3, 4. So first of all, we'll write down the fact that the total distance is going to be the area under the graph. And then, as I say, it's just a matter of finding each of those areas carefully. So the first one is a triangle with 10 and height 4, so that's a half times 10 times 4. And then we have a rectangle, so 10 to 20, height 4, so that's 10 times 4. Then we have a little trapezium. So remember, the area of a trapezium is a half of A plus B times h, the perpendicular distance between them. A and B are the two parallel sides, so that's going to be a half of 4 plus 7, the sum of the two parallel sides, and the distance between them is 10. And then the last one, a triangle, which the area will be a half of 10 times 7. So if we work all that out, we end up with a 20 plus a 40 plus a 55 and 35, and that gives us a total distance of 150 meters. So if we move on to part B, C and D, and we should get all these done on one slide. The average speed, remember, is the total distance over the total time. And the total distance we've just found, which was 150, and of course the total time we can read off our graph was 40 seconds, so that means we have 3.75 meters per second. And then in part C, we're asked to find the acceleration in the first 10 seconds. So we want the gradient of this line. So remember that the acceleration is given by the gradient of this line, which will be, it's gone 4 up, so the velocity was 4, and it's reached that velocity of 4 in 10 seconds. So velocity over time, 4 over 10 is 0.4 meters per second squared. And then the last thing in part D, we're told that the mass of the train is 200 tons. Now we do need to be careful because 200 tons, remember, we need to bring that into kilograms. So that means we're multiplying by 1,000, so that's another 3 noughts. So the mass of our train is 200,000 kilograms, and what we're asked to do is to find the magnitude of the resultant force acting on the train during the first 10 seconds. So during that first 10 seconds, remember, the acceleration is 0.4. So we're going to use F equals ma, where the mass now we've worked out in kilograms is 200,000 and the acceleration is 0.4. And if we multiply those together, we end up with 80,000 newtons. Remember, the unit of force is a newton. So if we just go back and have a little look at how the marks have been awarded. So there were 4 marks for that first part. So what happened in that first part? You got a method mark if you got one term correct when you were working out the total area. You got 2 method marks if you got a second term, and then you got 3 an accuracy mark if you got it all correct. So all 4 terms, and then you got another accuracy mark for getting the answer right. So there were 4 altogether, 4 marks for that question. When it comes to part B, then there was 1 mark for their total distance divided by 40. So you got a method mark there and an accuracy mark for 3.75. Now you would have got a follow-on if you'd worked out the total distance incorrectly. There would have been a follow-on mark here. The acceleration, you got a method mark for any division involving 10 and 4, and then you got an accuracy mark for getting 0.4. So again, 2 marks there. And then in part D again 2 marks. So as long as you were multiplying the mass times the acceleration, even if you didn't actually remember to bring it into kilograms, you would have got a method mark, and then you got an accuracy mark for getting it completely correct. So don't forget that if you want to watch further videos, then you can do so by going to the Further Maths Support Programme website and following the link for online revision.